We are live. Good morning, good evening, good afternoon, everybody. It is morning again here where I am. So I got my coffee, taking a sip, and I'm super excited. It's week 4 already. They say time flies when you're having fun, and I'm having a blast with Blockhack. We've had a great a series of talks. We have amazing projects being built right now, and we have great talk going on in the Discord. So I'm excited, and we're back again with Dave McKay. He's here to talk about Hyperledger Fabric with us today. So if you guys haven't already checked it out, he did a talk a couple days ago about self-sovereign identity, which was amazing. I highly suggest you guys check it out. It's going to be here much sooner than a lot of us might think. But yeah, I would like to welcome Dave to the cast again. Thank you very much for being here again. How are you doing today?
Good, good. Thanks, Jordan. Doing great. I actually had some time off this weekend, so I got some rest. Ready to go for another week.
Awesome. Cool. So before we jump into your workshop, I want to get to know you a little bit better. And we already been chatting since our last workshop. So we know a bit about you already. So let's dig a little bit deeper into what you're working on. So last time we talked about self-sovereign identity, and I know you're working on a project in that space, and you're commercializing the identity as a thing. So I want to dig into that a little bit more. What does commercialization of identity actually mean? Are people going to have to pay for it, and like how does that affect the self-sovereignty of the space?
Yeah, so it's, as I said last time, it's kind of a progressive idea, sort of privacy by design. And the way I see this working and the way I'm working towards it working is individuals have their own identity wallet, and you get that for free. And you can choose between a whole bunch of variety of wallets that are out there. The people who gain from this and have to pay for it are the organizations, the enterprises. The government, academia, corporations, associations, that sort of thing. So they're issuing credentials and they're verifying credentials, and that's a huge gain for them to be able to do that. And instead of them integrating, you, the person in between, who have the vested interest in getting all this data correct between the different places, you get to control that the crux between all of these, and you don't have to pay anything for it. Because I don't want to pay for it, and no one's going to adopt it. If you had to pay like $5 a month to have your identity wallet, yeah, good luck getting that stuff out there. It's like browsers. Back in the early days of the browsers, there were some browsers you had to pay for. I don't remember the names of them even, so they're gone. Yeah, the browser is free. It's the people who are putting the websites together and hosting that, they pay for those services. And that's when I talk about commercializing, I want to get the wallet out for free so that people will actually have that and use it, and that corporations will then say, okay, now we want to get on board with this as well. So we will pay people like Dave McKay money to integrate these systems for us.
That is amazing. That makes total sense. And you mentioned like paying for browsers. I remember when the internet first came out, at least, yeah, when I was a kid, you had that AOL disc that came in the mail, and you had to put it in your thing, and like you get 10 minutes on the internet. Oh man, how times have changed. It's so very interesting. And like what you were saying about having the governments and commercial industries pay for this makes a whole lot of sense. I think we have the value that they want, and right now the paradigm is flipped the other way, where they're monetizing on our data, and I think it's time to switch that paradigm. And I think that your project and projects like it are going to be moving towards that direction. So I'm glad to hear the individual's not paying for it. We're gonna charge the industries that want to use our data. That makes a whole lot of sense.
And it's not even that expensive either for them to run a node on this when the system is all up and running and millions of people on it. May cost them like $10,000 to $15,000 a year to run a node. So that's small potatoes to be able to participate and have identity backing all transactions that go on. So I think it'll be an easy sell. Well, that's what I'm hoping for.
Yeah. That's great. And so digging into the government side of that, we, in Canada, at least just south of the border, there's a lot of chatter going on. They have an election going on, and, voter fraud is a huge topic in the space. And so how do you see self-sovereign identity working to potentially alleviate some of that fear through voting? Like, is this possible? Is it achievable? Can we build something that's safe?
I think we're still a generation or two away from electronic voting. I'm still happy. I guess maybe because I have a Canadian perspective on it. Because in Canada, it's really easy to vote because, probably our biggest ballot is the municipal election because you have so many jokers running for mayor. Whereas in the US, when they have an election, they have a lot of sort of municipal positions that we would normally not think of, something like that you always hear about. They vote for dog catcher and sheriff, and then they have their state stuff and they have their federal on there. And so so your federal, you're voting for your senator, the president, and for your congressperson. So it's, and then the same thing in your state. And there's so many people running for this. It's pages and pages. So the ballot is quite complicated. But the problem with like self-sovereign identity right now works great on your mobile phone, but not everyone has a mobile phone. So I don't want to disenfranchise those who don't have the technology, don't want to use the technology, can't afford the technology. So I'm all for paper ballots until such time as we get all that worked out.
Very interesting. Yeah, so I was a little bit more optimistic, but I would definitely defer to your expertise on this. I feel like it would help a lot of folks, especially during this time, like where we don't want to be congregating in public areas as much and stuff like that. But yeah, I guess time will tell. Maybe it is also going to be accelerated due to global circumstances.
Yeah, I think the concept of the mail-in ballot for the US certainly makes a lot more sense, because it allows the person to take the time to review these pages and pages of things to fill out. Now, eventually, it just doesn't make sense anymore. Having all that paper shipped around is kind of ridiculous. But until such a time, I think that's the solution in a pandemic.
Yeah, that makes a lot of sense. Okay, so let's dive into a little bit more on that topic that we're going to talk about today. So I know you have a lot of experience with Ethereum and more recently a lot of experience with Hyperledger Fabric. So what do you kind of see as the difference between the two? And what kind of advice would you give to people that want to build in these spaces? Like, what are the use cases, and like how do you determine which one to use?
Yeah, I get a little deeper on that into the talk, but I can give a basic difference here. So Ethereum is a public blockchain. Anyone can participate. You run on anonymously, and it's really great for individuals doing things with each other or sort of consumer-based activity. As soon as you try to bring it into a corporate environment, it doesn't make sense anymore. Corporations need to know who they're dealing with, and you need to know who that corporation is. So that's where the promise of blockchain was great, but when corporations looked at this and they were very excited about having a system that they could trust in transactions and having this immutability. So they went and rolled up their own systems. There's a couple of them. There's R3 Corda, which is a European consortium, has created this, and then IBM in North America created the IBM blockchain. They soon realized that they couldn't be the company behind it, and so they transferred over to the Hyperledger Foundation, and it became Hyperledger Fabric. And it's more geared towards enterprise work, particularly in things where it's between multiple companies. So where you see this being used is in supply chain situations, or anything where there's documents that are passed around. Because what's been happening is people use things like DocuSign, which is it's a bit of a security nightmare. I do a lot of work in cybersecurity as well, and so I look at DocuSign, I just shake my head. But it's better than having to have people fly around to sign documents, and or people emailing them or faxing them, whatever crazy solutions. Couriering, that used to be a big thing before faxes. You'd have to put all your documents together and courier it off to someone, and they would sign it, and they'd have to courier it back to another party. And you'd have to trust that no one swapped out any papers in between. So people would have to sign, like, initial every single paper all the way through, so you can make sure that these things didn't happen. And then fax machines came out, and that was supposed to replace it all, but that was just a nightmare where it's like photocopying a photocopy of a photocopy. It just degrades. So yeah, I think we're heading into a world where we can trust digital signatures. We have a sort of a rudimentary identity associated with the permission blockchain. So this is going to replace a lot of marketplaces where it's enterprise talking to other enterprises, and then people getting involved in as well. A good example would be an insurance claim. So let's say someone smashes into your car. You now have two individuals. You have two insurance companies. You have appraisers. You have repair places. You have all of these people, and there's a whole bunch of documents that need to be filled out and signed and passed around. The police report. So all of this. And so it tends to be paper because you have these silos. Each company runs their own system, but for them to integrate with all the other insurance companies, with all the appraisers, with all the repair places, with all the police departments, it just doesn't make any sense. So having a decentralized system, it could solve huge problems in that marketplace.
Wow, tons of applications here. It's amazing. But there's always, like with most things, the right tool needs to be applied to the right job. So I look forward to finding out and teasing apart a little bit more on like the specific use case for Hyperledger during your talk. So we are going to jump into that right now. But before I do that, I want to draw the folks that have trickled in here now to take a look down at the bottom of the screen. We have an Ask a Question button. So if at any point in time you have questions for Dave, please drop it in there. And if you see a question there that you already that somebody asked that you want to get answered, give it an upvote so we can make sure we're getting to the most important questions for you. And of course, we have another poll just beside our Ask a Question button. So let's take a look at what we got on our poll today. Have you done any develop using Hyperledger Fabric? We have 20% saying they've done a little, and we've got 80% saying not yet, but that's why they're here. So they're looking forward to learning a little bit more. And let's see, have you done any Ethereum development before? We have got 40% saying a little bit, 20% saying a lot, and still 40% saying not yet, but they want to learn. So maybe we do a little bit of help for those folks that haven't done it, a little bit more of an explanation. And then, are you interested in building enterprise solutions or consumer solutions? Because as we were just talking about, there's different tools for these different arenas, and we're going to talk a little bit more specifically about those tools. So we've got about 17% wanting to build enterprise area, and 67% looking to go more the consumer route, and another 17% wanting to do both. So this conversation is definitely for everyone in the room. I welcome you all here. And on that note, I'm going to pass over the stream to Dave, who's going to take us on a journey into Hyperledger Fabric. Thanks for being here, Dave. And for those of you that missed my introduction last time, Dave is a blockchain instructor for the George Brown Blockchain Development Program. He is the CTO of Northern Block and the technical lead at the Ryerson Cybersecurity Research Lab. He has over 35 years of software development management with several companies and is involved with the commercialization of self-sovereign identity in Canada. He currently is the co-chair of the Innovation Experts Committee of the Digital Identity and Authentication Council of Canada, as a mouthful, and has just launched the non-for-profit Canadian Credential Network. So I'd like all of you to help me with a digital round of applause. Welcome Dave McKay. Thanks, Dave.
All right, thanks. So from the poll results we have, some of you have some experience in Ethereum, and that's where I got started. I learned Ethereum first, and I found that in certain use cases it was becoming problematic. So, you know, a token that represented a token that had tokens that did this and that, it seemed like an architecture that could work, but in practice it was clumsy. So I had sort of made fun of Hyperledger Fabric, thinking, it's an enterprise thing, and that's what enterprise people use, and it's not a true blockchain. And I started looking into it, and it's like, okay, well, this actually solves a lot of problems that I wasn't seeing before. And just to, for the people who haven't done blockchain development, the reason there are a couple of great properties of blockchain systems. And so one is the immutability. So if you write something to the blockchain, you can't change that. So now you can have a second version of it. So you can have your original version, you can create a new version, which is a change, but you can't get rid of what the original was. And everyone can see who made the change and what the change was. So it gives you a permanent audit trail. And that's great for things like accounting. And that's why we use it for, we call it a ledger. Sometimes it's a distributed ledger is what they'll call a blockchain. And you don't want to have your accounting where you can change things, which it's pretty important, particularly when it's your money or other things like that. So that kind of capability was really interesting to enterprises. And so they like, we want this kind of thing. We want this immutability. We want to have the trust. We want to have the decentralized nature of this. We want to have the distributed part. We want to have all the security. So all of these things were very appealing to enterprises. The difference there was that, let's get into it here. Basically, they didn't like the anonymity. So to solve the double spend problem with digital money, Bitcoin came up with this idea of, hey, instead of trying to make something unique by having one copy and trying to protect that, we're going to make something unique by having multiple copies and everybody agree on what that thing is. And so that allowed a couple things. It allowed us to have accounts where we can control exactly how much is in there and everyone can agree on it. You can't spoof it. And it allowed these immutable ledgers and state data. And state data is something it's a shared piece of data where everyone agrees on what the value of it is. So this is some really powerful stuff. We've never been able to have unique things on the internet that people couldn't copy and steal. We've never had a way of having value transfer on the internet because if I could copy something, let's say we made digital money and I just did a file copy of digital money, I could give that to someone and make another file copy, give that to someone else. So how do you control that? And so it's controlled by blockchain technology. But the Bitcoin way of approaching it was, okay, everything's going to be transparent. And because it's transparent, everyone can see all the activity. And not everyone wants, you don't want everyone to see all of your activity. So the trade-off there is they decide to make the accounts anonymous. So if you have an anonymous account, someone can see all the activity, but they don't know it's you. And it's up to you if you want to protect your anonymity. That's great, and you can do that. Now that had a lot of appeal for the initial users of blockchain, which were sort of cypherpunks who were sort of anarcho fascist type people who want a different world and bring the banks down on that. But this technology had an appeal to the other side, the banks and people who wanted to be able to have more controlled and secure systems for managing business transactions. So they created a new type of blockchain where it's permissioned. So with permissions, that means you have a user account associated with transactions. So you know who that user is that initiated the transaction, you know who it went to. Instead of just having anybody participate in the blockchain, so something like Bitcoin or Ethereum, it's a free-for-all. You can set up a node and away you go. You can use something like you can participate with someone else's node, and you're immediately up on there and you're working on it. Anyone can put smart contracts in there. Anyone can participate. So enterprises don't want that. They only want to have people on their blockchain that they know and they trust. And so they can grant and revoke access to the actual blockchain itself. And the same thing with the smart contracts that are in there. They don't want just any old willy-nilly contracts up there. These are contracts that are agreed upon by the different participants in the network. And so that you don't have to have that same level of auditing that you'd have to do on a smart contract that you put onto, let's say, something like Ethereum. And the other thing is the users that are in the system are all part of organizations. So it's organizations that are joining this, and they're bringing their people on board, and they're vouching for those people. And so when you do a transaction, you're doing a transaction as a representative of that organization. So this is the kind of thing that has to be in place for enterprises to use this type of technology. So in doing this, what sort of benefits do they gain that are different from the benefits you'd get from a public blockchain? Okay, so transactions have organizations and users associated with them. So this is a benefit because if you are doing accounting or auditing, you need to know exactly who you're sending these goods to, or who has purchased these things. You can't have a corporation with anonymous accounts they're sending things to or receiving money from. You couldn't have political parties where you want to have that. You can see as soon as you have this sort of anonymity, then you have the possibility of fraud, where someone in your company can say, oh yeah, I sent the money to this anonymous company, which happens to be them. So you don't want to have that, so you have users associated with them. The other interesting thing you can do is you can have confidential and private data. So confidential transactions, meaning that you don't want your competitors to see everything you do. You may not even want your customers to see everything. So a lot of companies will negotiate pricing with their customers, and so they may have preferred pricing based on different things that their customer brings to them. Maybe it's a higher volume of activity, or there's an extra credibility, or they're just better negotiators. So having confidential transactions means not everyone can see all the transactions. And having private data means you can hide certain aspects of the transaction from other parties. And what other people will see is just a hash of that. So between the two people doing the transaction, they can see all the data. Other people just see a hash of that private area. And if later on there's some sort of conflict, the two parties can present the full detail of it, and the one that matches the hash is the correct one. Organizations have control over shared smart contracts. This is good. It's not something where these are contracts where you have a different owner out there who can do things that you don't want. Another interesting thing is the faster transaction completion times. So sometimes on Ethereum or Bitcoin, it could take minutes to complete a transaction, whereas on Hyperledger Fabric, it can be seconds for it complete. And the transaction throughput. Because you're having to find consensus across an entire network, it can take a long time. And so you're only getting between 5 and 20 transactions per second on something like Ethereum. Whereas with Hyperledger Fabric, you're getting 3 to 15,000, sometimes even 20,000 transactions per second. So the kind of numbers that large enterprises interacting with each other would be seeing. You also have more control over network settings. So there's when you set up a node for, let's say, Ethereum or Bitcoin, it's sort of pre-done with those settings, but and that's the setting so you can have maximum trust, and you may not trust the different participants on your network, so it does a lot of things for you. When you set up Hyperledger Fabric, you have an awful lot of parameters that you can set and change to give you the exact level of security and openness you want. So it's kind of a balance between them. Another really important benefit you get out of this is you can store structured data. So if you've ever worked with programming of Bitcoin or Ethereum, you have this little chunk of extra data you can do, and just a binary blob of data. So it's up to you to sort of translate how that would go. So if you're trying to store something structured, you would have to serialize that data, put it in there, and when you pull it out, you have to deserialize it and work with it. So it's unless someone knows the structure of your data, it makes no sense. It's just a bunch of hex values. Whereas in Hyperledger Fabric, you can store your stuff as JSON data. So JSON data is a very good way to have. Not only is it a structure that you can have where you have key value pairs, and the values can be other key value pairs or things like arrays or numbers, strings, but you can also search across that. So it's more in tune with the way that people are doing development these days. A lot of mobile and web development, you're using JSON data and passing that around. A lot of APIs, like REST APIs, you tend to sort of serialize JSON data, pass it across, and turn it back to JSON. So let's sort of do a quick summary of this Ethereum versus Hyperledger. So Ethereum, you've got anonymous accounts. So this is great. So you're doing all your activity, and while you can see exactly all your activity and you can audit your activity, no one else knows it's your activity. Whereas in Fabric, you have specific user accounts. You know exactly who the people are that transact. On Ethereum, it's a public network. Anyone can access it. In Hyperledger, people have to be given permission to join the network, to join a channel, to be part of an organization, to run things like Chaincode. On Ethereum, you have native coin, and you can create tokens. Sorry, I got a really noisy cat here. Over here. You don't have that. This is this was what really confused me at first. There's no native coin for Hyperledger Fabric. There's no Fab coin that you can see on an exchange anywhere. You can do tokens with it, but it's really limited. It doesn't really work very well. I wouldn't recommend it. So if you are transferring actual value, then a cryptocurrency on a public blockchain is the way to do it, because you can avoid the double spend. More often, you would use a permissioned blockchain for a transfer of information. So it could be moving invoices around, but not doing the actual payment. It might be someone says Hyperledger cat. Yeah, you don't have the sort of non-fungible tokens where you can do crypto kitties. It's really not something you could do. Or well, if you do, it's very limited in what you can do with it. So that's a big difference. Another thing is on public blockchains, because you're storing it on every single node, it's really expensive to store things. I had a client, they wanted to scan a document, and for every transaction, they wanted to store that. And I said, yeah, what are you talking about? That's ridiculous. They're going, well, how expensive can it be? And I calculated out for them. It was like, I don't know, $18,000 based on the current value of what gas prices were going for. It's about $18,000 to store a scanned document of about 5 or 6 megabytes. And they were like, oh. Whereas when you're in Hyperledger Fabric, it's different. It's not the entire history of every single transaction. It's just the transactions in the channels you're participating in. So you can store a lot more, and you don't have these huge terabytes of data that doesn't apply to you in any way. On Ethereum, because the smart contract is running in this sort of global computer where every single node runs the exact same code all at the same time, or sort of the same time, you have to very much limit the language that it's used, and you limit what the contracts can do. So over in a permissioned world where you know who all the people are and they've all agreed upon the smart contract, you have this concept of Chaincode. And so Chaincode can be a lot more powerful. You have a lot more language options for working with it. So it gives you a lot more flexibility on it. So Ethereum is using a public network. Hyperledger is you set up your own private network. and you have people join it. So maybe it's the the gold mining and processing industry decides they all want to have their own Hyperledger Fabric for their own supply chain. They'll set that up, and that's their thing. And then maybe over somewhere else, there's the green produce farmers who make salad type things. They set up a supply chain. The shipping industry has a supply chain. Certain financial industries that are providing information, they'll have their own private networks. Anytime you want to do a transaction on a public blockchain, is you have to pay for that. And what you're doing is you're paying to support the people who are running the different nodes that are operating the system. And originally that was just supposed to be home users. So everybody who used cryptocurrency was supposed to run their own node. And every once in a while you'd get this little lottery ticket where you get a free token to help pay for the fact that you're running your system. So you'd pay out, and every once in a while you get paid back. And so it was a nice little balance. But somehow it turned into an industry on its own where people have these mining farms because they realized if they did it fast and they did it in quantity, they could actually turn it into a profit. Well, over in the world of a private network, there are no fees because there is no built-in coin. So there's no fees being charged. And because there's no fees being charged, there's no transaction fees. And then, as I said, you get 5 to 25 transactions per second and 3,000 to 5,000. These are pretty rough. I think you can do a little higher than this. And you can go way higher than this. And it all depends on the types of transactions that you're doing. Okay, so what I want to do is sort of build up what it looks like, because it's a different world than you would see on Bitcoin or Ethereum. So the first concept is you have your own network. So this is your private network. You've purpose-built it for the industry that you're working with. So quite often these things are put together by an association that would represent that industry. And then you give organizations permission to join the network. So you say, okay, so I'm doing a mining one. Well, let's bring in the mining companies in. Let's bring in the processing companies along, the companies that sell mining equipment, the people who do tests, assays of the ores and things like that. And then you can have multiple channels within this network. So let's get there in a second. So let's bring on 2 example organizations here. So as soon as they're in this network, so these organizations have been given permission to join this network. Each organization has its own admin, and they can have their own, they can add their own users, they can onboard their own people, and they're responsible for approving chain code. And they'll also run their own nodes. So let's take a look at the nodes. So in the lands of, let's say, Ethereum or Bitcoin, there's like a single type of node that, well, there's different vendors who make it, but there's a protocol for nodes. And so you have a node, and they can all be treated the same. In this world, you have different types of nodes. So the main nodes are called peer nodes, and the peer nodes give you a distributed property. So within an organization itself, so if one node goes down, you have another node up and running. As well as between organizations. So, if I have 2 here and they have 2 there, several of these can go down, but I still have a copy of the data here, and I can rebuild from that. You tend to have anchor nodes, which are the ones that do the communication with each other. So instead of every single node talking to all the other nodes, you just have a designated node that talks to other organizations. You have an orderer. So the orderers tend to take care of a lot of the work that you would get in consensus. So your orderer is going to decide what order of transactions happen. Your peer nodes also do something called endorsing. So your peer node will check to see, hey, this code that's running, is it trying to change any state data it doesn't have access to? And if it does try to do that, then the endorser can say, no, we're not going to run this transaction. So that's an interesting thing, is the peer nodes can actually be endorsers, and they can check to say, okay, is this chain code trying to do something outside its limits, and stop it there. So instead of trying to catch it at the language level, like over on Ethereum, you've got Solidity is the language they have, and it's very limited in what it can do, and they try to sandbox it in that way. In this case, you have a lot of freedom, and you just run the endorser, and it'll say, "Oh, okay, yeah, I know you're overstepping your bounds, so I'm not going to let you do that." The order for your transaction ordering, your certificate authority. This is for identity verification, whereas in let's say the worlds of Ethereum or Bitcoin, your account ID actually has the information that people can use to pull your public key from, and your private key is kept separate. The certificate authority is going to be publishing the public keys out to people. So if someone says, "Hey, I need the public key for a user that's on there," they can query the certificate authority to get that using sort of X509 certs. The other interesting thing here is they've taken a NoSQL database, CouchDB. This is an Apache project, and they've put this in here to store the state data. And this is where I was talking about how you can have JSON data. So just like you'd store JSON data in a MongoDB, you can store it in CouchDB and have the immutable capabilities on it. So people can't go in and change that data, because when you're running this isn't on a it's going to be shared between these. So any change that happens here is going to happen over here. And so if I go and try to change it here, I will no longer match with what's going there. The only way I could change this is by running it through some Chaincode and then having the synchronization between these. And if I don't sync with them, I'm out of sync, and I'm not going to, it's just going to give errors, and I can't participate on the network anymore. Now you have the concept of a channel. So your network has all of the different organizations in it. You can have multiple channels, and your channels represent who you are interacting with. So if this network is all of the mining companies in the world, well, not every mining company interacts with every other mining company. So if I have a mining company, an assaying company, and like a shipping company, they can all have their channel together. And from that, they have their own ledger. So it's like having a blockchain within a blockchain. And the nice thing is, for this ledger, it's only going to hold the transactions between these parties within this channel. So org3 won't see anything that's happening on this ledger, and they shouldn't, because this is internal business to these people. So how much I'm shipping to them, what I'm paying for it, the quality of it, all that kind of stuff, that's internal information to a corporations, and corporations need that to operate, because they have these sort of secretive natures to them. Also, they can run their own chain code. So these are their own smart contracts specifically for this channel. So org3 here can't affect this smart contract, can't call the smart contract, doesn't even know it exists. So it's, but I could also have org1 and org3 could be part of a channel, and they would have their own ledger and their own smart contracts. I could have another one that represents org1, 2, and 3. I could have an org4 and org5 and org6, and maybe they have their own channel. So these combinations of channels and bringing these organizations together this way gives the confidentiality that you don't have in a public blockchain.
Can I ask a quick question while you're right there, Dave?
Sure.
So for those that are familiar with Ethereum, might have heard of the concept of a state channel. Is there any correlation that can be drawn between a state channel and the channel in the context which you're talking about right now?
I'm not familiar with what a state channel is.
Okay, fair enough. We don't need to go into it then. I was just wondering. It sounds similar where you open up a channel between two parties, and you don't need to settle everything on chain immediately until you close the channel. But
okay, so like a side chain is what you're saying.
Kind of like that.
Yeah, so side chains are something tacked on to the side of public blockchains like Ethereum to try to give you this confidentiality where, like the Lightning Network, where there'll be a whole bunch of transactions that take place, and at the end, it'll come to consensus and close it off. And so that way, people who weren't part of that side chain don't get the exact details, but you still keep the continuity so you don't have double spend. In my opinion, it's a bit of a kludge. So this is what the JP Morgan people invested heavily in when they forked Ethereum to create their own part. And so they sort of added these side chain things on top. Does it make it run a little faster? Maybe. Does it give you some confidentiality? A bit. But it messes up with public auditability. It's not really something that was built into the protocol to begin with. So it tries to give you some of these capabilities, but also tries to keep so that you can actually avoid double spend. So in this sort of situation, you don't have a token or a coin moving around. So that's why you're allowed to have these different channels, and you can have this confidentiality, because it's not like this org has a number of coins and these guys have coins and they've traded their coins to each other, and this person doesn't know that they've spent it. And now this guy and this guy have a channel, and if they traded coins, this person wouldn't know. If that was the case, then the accounting for your coins goes out of whack. So this is the big reason why they don't have native coins on this. Is this whole channel thing just breaks it completely. So you've got a few options for writing your chain code. So basically you can write it in Go, you can write JavaScript, you can write Java. There are a few other languages they're working on to put this in. I think there's a Python one coming out, a few others. They handle it a little bit differently. So in the world of Ethereum, so you have your code and you publish that up to the blockchain, you pay some money to have it put up there, and it creates its own address, because basically it's an account that's up there. Where this is different, you get your code, you have to package it up, and it's a signed package saying, hey, I put this together, I've packaged it. You then put it up onto a peer node, so you instantiate it there. And then you approve it. And then multiple organizations put the chain code up there and they approve that. And once a majority, well, depending on the rules you put in, so once a majority of organizations within a channel have approved that package of chain code, then it can actually get invoked. And invoked is running, it's kind of like running the constructor in Solidity. So you run it for the first time and you sort of set up any variables and things like that. So this is multiple step process. It's even more clumsy to get code into Fabric than it is to get it onto Ethereum. And so for that case, what I recommend to a lot of people is you do the development to get everything working before you get it on the blockchain, and then package and put it up there, because going through these steps and having multiple peers of different organizations have to approve it is a real pain. So you don't want to change your code a lot. So your chain code has access to the state data. So you see this get and put kind of stuff here. This is actually taking the, getting the JSON data from the CouchDB or whatever storage you're using, and putting it as writing it in there. And at no point do you have to worry about gas fees or having a gas limit, because that isn't part of this world here. So CouchDB is this is what I'm saying. You can run this without CouchDB. There's LevelDB, which is like writing to a flat file. What you are doing here is using a NoSQL database, and if you're familiar with MongoDB, CouchDB is very similar, except for the tools aren't as good. It's pretty much caught up in speed, because MongoDB is very fast. When it first came out, it was kind of slow, but now with MongoDB, you're getting speeds approaching SQL databases like MySQL or all the other options that you've got out there. You're storing the shared state data. So if, let's say it's an invoice, so I have all that invoice information that I put in there. I can see that, my customer can see that, the accounting company can see that, the shipping company may want to see part of that. So there's all these different parties that can see that exact same state data. And again, you have this immutable property, and you have the versioning, and you have the distributed aspects of it. So all of the power of the that a blockchain gives you. It's in JSON format. I can't tell you how helpful that is, because JSON, there's a couple things with JSON. One is, as I said before, it's used in all the mobile and web development and a lot of server development that goes on. It's also slightly human readable. If it's a small amount of JSON, yeah, you can read it. A large JSON document gets a little unwieldy pretty fast. But they also allow JSON query. So if you have this data in JSON, you can actually query against this database instead of having to read the data up, check it, and then discard it, and then get the next one and check it, like you would in, let's say, the type of world you have with Ethereum. And in Ethereum, you can't walk through the records because you'll run out of gas pretty soon. So this is a really powerful thing. So a lot of times I'll tell people, if you're trying to do something in Ethereum that seems like it's a database, you're doing it wrong. You have to give up that sort of ability, because you can't iterate across the records. You have to have a key to look something up. Now you could have a key of that gives you something you look up, and you have another key, so you can have sort of these nested pieces, but you can't walk through that entire list. And so you can have more, because of that, you can have much more sophisticated data structures. So in Ethereum and Solidity, you have a lot of mappings. And you can do combinations of mappings and arrays to sort of get around these problems. But again, you get the limits of what you can do in size because of the gas fees. So a lot of that goes away. And then you can store more stuff. So instead of, $18,000 to store a scanned document, you could actually store that document in there into the Hyperledger Fabric one. You probably shouldn't. You should probably use IPFS, just like on Ethereum. You should use that for storing that. But what you can do is you can gather more and more information. So if, let's say, it's a supply chain, and you have a batch of, let's say you're making solvents. So you create a batch of chemicals, and then some of those chemicals you'd send to a company that's making glue. So they take the other chemicals plus your solvent, they put that together. And so as it goes through each step, you're getting more information. Where did it start from? What were the test results on it? Who shipped it? Who received it? What did they combine it with? Again, it was shipped, it was tested, it was packaged, it was sent off to a warehouse, it was sent to a retailer, and was sold on this date. So you could have this all that information gathered and associated with the record. Whereas storing all of that on a public blockchain is it's way too expensive, just for like a box of glue. It's just not going to happen. But a system like this, you can have all that information, you can store that, and you can track that along as you go. And it's not very expensive because it's not shared with the entire world. It's only shared with those people in that channel for that supply chain. Now, how do you talk to this thing? Because blockchains are blockchains. They don't have a user interface. They tend to operate at the same level as like a protocol does. So it's not like you have a user interface to TCP/IP. So we have the Fabric SDK. So the organization calls the SDK, which creates transactions and sends it off to the peer nodes to be endorsed and ordered and put into the blockchain. You use peer commands. I'm going to be doing a little bit of a demo. So I'll run through the, there's the system sort of default tutorial that they give you with Hyperledger Fabric. We'll do that, and if we have time, I think we have time, I'm getting through this pretty quickly, we'll actually create our own little Chaincode piece and be able to call that. Yeah, so you have these peer commands, so peer Chaincode invoke. So remember I was talking about how you, the first time you call something. So this is the first, they've got this Chaincode, and it was packaged, it was instantiated, and now it's invoked. And they're telling which order to use. In this case, they've got some TLS security on here. They're referencing the different cert files they're using. So it's a complicated world when you're working here. And all they're doing is they're telling it to invoke. They're invoking call A and sending it two values, B and 10. So all of that work to do that. And then it came back with their result here. Yeah, and then they're doing a few other things. So this is just an example of kind of what it looks like in that world. It's a bit of a messy world. So where is this useful? So we touched on this a bit at the very top when I was talking to Joran. So supply chain is a great use case for this. One of the early adopters of this was Walmart. So Walmart is the huge retailer across the world. And so they buy things sort of at a wholesale level, and they supply their stores with all of this. And so they have a huge supply chain where they're managing all of the logistics for getting all their stuff around. For them, things like recalls are very expensive. So remember a couple of years back, there was an E. coli scare with packaged salads. And what they did was they didn't know where it was coming from. So they took all of the leafy greens off the shelves in North America. That was billions of dollars to handle that. So Walmart looked at that and said, well, okay, if we took a fraction of the $1 billion to build out a system that could track the provenance of these leafy greens, the next time something like that happens, it's not going to cost us billions of dollars. It's going to cost whatever the system was to develop, which might be 10 million. So that's a huge difference. And then the next time it happens after that, and the time it happens after that, the system's paid for itself multiple times over. So for supply chain like that, you'd have to have your growers, your shippers, your warehouses, all those people would have to be involved in the supply chain where you're tracking the goods as it goes through. And then when it gets to a store and someone has a bagged salad and it makes them sick, and maybe someone gets almost dead or they die, they can look back at that bagged salad and they can say, what store did it come from? Or if there's a number on that bagged salad, they can, usually throw it out so you don't have the number. But if you have the number, they could immediately trace that right back to where it happened and where all of those other bags are. We know the store it was purchased in, and we know any other store that was issued stuff from that batch. But you can trace that right back. So all of a sudden, you take off the shelf just the brand and just the things that were part of that individual supply chain, as opposed to everything all across North America. Insurance is great. I talked a little bit about how you have multiple parties here. So you have whoever holds the insurance, whoever's making a claim on it, claims adjusters, the multiple companies involved if you have car insurance. Real estate's a great one, because real estate, you have a buyer, you have a seller. They each have their own agents. Sometimes they have lawyers involved. There's mortgage brokers. There's appraisers. There's governments. You may have the property registry. You have all these different parties, and all this is paper that's all floating around. And it's overly complicated. It takes a long time, and a lot of times you have to be there in person to sign this. So buying real estate somewhere else means you have to fly around to it. So it's kind of annoying. Compliance reporting. So if you are having to report things back to the government, this is a lot of work, particularly if it's across multiple companies. So that's a great piece to have using a permission blockchain. Complex decentralized marketplaces. An example of this would be, let's say, the aeronautical used part marketplace. So airplanes are really complicated devices that have millions of different parts that make them up. And each part has sort of a different life cycle of how long it is good for. And so if a part breaks down, it can go get repaired. And so it'll immediately be replaced by a new part or another refurbished part. But that repaired part, once it's repaired, can be sold to another company to put into their plane. And some parts, if a plane is retired, but maybe the part is newer than the plane, or the part has longer life than the plane had, that part can be taken out and resold. So, but you have multiple companies who are doing the repairs, the ownerships of the planes, the transportation of these items around, the installation of these. So all of these different companies all interacting with each other. It's a very complicated decentralized marketplace. You need to have certificates of authenticity. You need to have provenance of these parts to show how long they've been on planes. You need to have approvals from things like the FAA. So it's not like selling books with Amazon. This is a whole other piece where a blockchain can jump in and take care. Healthcare is another one. Healthcare, you have multiple hospitals, and within the hospitals, you have multiple departments. You have caregivers that are outside of the hospital. So maybe if you're going in for surgery, you'll have your surgeon, you'll have a nutritionist, you'll have a physiotherapist, you'll have a nursing staff. You have outside there in your primary care, which is your personal doctor and their staff, and then you'll have insurance companies, all these other things involved with it. And again, it's running across multiple systems and multiple companies. So it's the type of system that's great for a blockchain that works with decentralized stuff. So notice that none of these I talked about how the money is transferred around. So in a lot of cases, what they're doing is they're combining a public blockchain with a permission blockchain. So you'll see a lot of talk about using Stellar or using Ripple as a payment rail for this, because they're sort of put together for payment systems. You could also connect up and use Ethereum. You could have Bitcoin doing payments too. There's things like the Interledger protocol, which is great for connecting up and handling this. Another thing you can connect up to this is the thing I was talking about on Friday, the self-sovereign identity. So you have a basic identity with the users on here, but if you need extra information like, is this person a lawyer? For the airplane things, has this company been approved by the FAA to repair these parts or to set the settings on a certain machine to calibrate it? Yeah. So what I'd like to do is to take us through the demo. I don't think it's a great demo, but you can. What we'll do is we'll download the Hyperledger Fabric samples, and we'll get the we'll get the piece working that they have, and then we'll either modify it or we'll create a new one. So and hopefully we can do that within the hour that we have. So I have the getting started page here. So the prerequisites for this. You're going to need to run Ubuntu. And this is a good question. I just realized I upgraded my Windows subsystem for Linux to be, did I run it to Ubuntu 20? Well, let's find out. I forget the command for that. Well, if we do npm-v, okay, I think I did because I didn't have to reinstall npm or anything, so that's a pretty recent version. Okay, well, hopefully this will work for us. So we need a bunch of things, git curl, blah, 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 blah. I believe there is a, let's go back here. I think they have a script that will do all these preliminary things for you, prerequisites. Do they have the prereq script anymore? Okay. Oh, we're not using Mac OS. Okay, so I don't think we need to do any of that. Oh, let me just see. Maybe I have this on here already. Okay, I already have Docker on here, so I wonder if I do have. Oh. No, I don't think I have that there. Okay, so here's what we're going to do is we are going to go and grab the code. So let's do the install the samples, binaries, and whatever. So what we want to do is we are going to clone this. Git clone.
Dave, can you make the window a little bit smaller and then zoom it in, because like what you're typing is hidden behind our
right,
heads.
is the yeah. Okay, so let me. How far can I go down here?
That looks good right there. And if you can like give it a zoom, 1 or 2.
So let's increase the font size here. Is that easier to read?
100%. Yeah, that looks really good. Thank you.
Okay, great. Okay, so we've got this stuff. Let's see. So let's go to Fabric samples. Let me just explain what we've got here in the Fabric samples. So they give us a couple things. They give us a test network we can play with. So this would be setting up some organizations. It would be setting up a network and some channels that we could use to play around with. FabCar is it's an example application where it's just has a bunch of cars. I think it's a terrible example. I think they're replacing it soon. It'll show you how everything works, but I don't think it's very practical. Commercial paper is a bit better, but it's really complicated. The interest rate swaps is even more complicated. So yeah, so let's go back to getting started. Yeah, so we're going to run their test network now. So if we go into the test network, and we will bring it up. So let's go to that. So cd test network. Okay, and they have a shell script here that does a lot of work for us. This is going to do a whole bunch of peer commands for us. Let's take a quick peek at that. So they're going to do a bunch of things. Let's get down to the meat of this. So to bring this up, it's going to check to make sure we have the prerequisites installed. It's going to see if we've asked it. There's a bunch of parameters we can put in. Hey, do we want to run CouchDB with this? It wants to make sure it can run Docker Compose because we have some Docker images that we're going to be doing with this. And then at the end, it's going to do Docker PS, just tell us, hey, if this thing is up and running. And if it doesn't, then of course it's just going to die on us. It's going to say unable to start network. So let's try the. Let's bring our network up.
Sorry, Dave. Can you make the window a little bit more less tall again? Yeah.
Yeah. Sorry.
Yeah, that looks a lot better.
Right there.
Maybe a little bit more. Yeah, that looks good. Okay. And then when you're on the web page, if you can zoom that too a little bit, that would be good.
Okay.
Yes. Thank you.
Okay, so, right, so we want to bring it up. Now it gave us an error message there. Let's see what it told us. Okay, so we've installed, oh, so are we missing something? Samples, binaries, Docker images, blah, 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 blah. Oh, okay, so we need to bring these things over using curl. Oops. So this is going to bring over for us Fabric itself and the Docker images that we're going to be using when we use the Docker Compose. So this is the exciting world of blockchain development. Watching things download. If you go through and run these examples, so the nice thing is you can play with these all you want. You can do it if you have enough processing power on your machine. You can do it on your home machine. The other thing you can do is you could get a you can set up a Google Cloud Platform account, and they give you I think it's $300 US in credits. And so with that you can set up a machine, like I think it's like a, I don't know, quad processor, X amount of RAM, but whatever the, you can look up and find what the requirements are for running this. And then you can run it for like a couple of months before you have to shut the thing down. And then you can just get another email address and open up another one. But you should be able to, unless you have a really limited laptop, you should be able to run this locally. There is a plugin for Visual Studio Code that will set this environment up for you. I've never used it, but the sometimes I work with a guy from IBM and he swears by it. He says it's fantastic. It goes and it does all this work for you and it takes care of a lot of the complexities. It makes sure everything is set up and you're off to the races. I'm running the Windows subsystem for Linux. I highly recommend that if you're a Windows user. If you're a Mac user, you don't need that. You can, you should be able to run this on Mac OS. I believe I have done that in the past. Even though it's, they say it runs on Ubuntu, I found it runs on Mac OS just fine. And if you do set up the Google Cloud Platform, then just you create a virtual machine and you run Ubuntu 18.04, I think is what they've actually supported. I believe I've got 20 on here. I recently updated my machine. Otherwise, I would have had this on my machine already. What it's doing right now is it's bringing down. These are the Docker images. So these are the Docker image IDs. And we're on version Hyperledger Fabric 2.21. So I originally started working with Fabric at version 1.1, and it was frankly pretty unstable. When it got to version 1.4.4, that's when it started to be a stable system. And then they changed it to version 2, which changed a lot of things, and I had to throw out some code and start over again on several projects. So it is still in the early days for this stuff. The tools are very primitive. Because this is an enterprise system, I was trying to explain to one of the people I work with at Ryerson. They said, "Well, it's an IBM thing. Shouldn't it be all just you press a button and it all runs, and isn't that what enterprise systems are like? And I said, well, no, enterprise systems give you an awful lot of flexibility for adjusting them. So the tools and things reflect that. So it's not like a lovely GUI user interface for setting it up. It's down at the command line, and you have control to change a lot of things. So there's YAML files for the settings for the Docker Compose to allow you to change how your network is set up and how it behaves. So it gives you an awful lot of options for doing this. And while that's nice, that gives enterprise a lot of options for running their own network, it means you have to invest a lot of time understanding what all of these things do. And so that's why I recommend, if you're thinking of going into this, don't wait until you have a project. Start learning how to play with it now, because you may discover, even if you're heavily into the world of Ethereum, you may discover at some point where someone comes to you and they have a use case, and you realize, oh yeah, this use case is not great for Ethereum. I'm gonna have to use something else. You can either walk away from the business and recommend, oh, you should hire a Fabric person. Or if you've spent the time yourself learning it, you'll have another tool in your tool belt, and you can say, oh, this can be solved using Hyperledger Fabric, and I have the basic knowledge of this, and you'll have confidence on where to go with that. Okay, so let's try now bringing our network up. No, okay, so what am I missing now? I suppose I should follow their instructions. Blah, 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 blah. Oh, right, I gotta do this stuff. Okay. Not to add your path environment variables, these can be picked up without fully qualifying the path to each binary. Okay, so where did all this stuff go? So I've got the network here. Okay, so bin subdirectory. So let's go to cd fabric samples dash LA. And there's the bin. Okay, so all of these things are here. So what we want to do is so our path is tilde slash projects fabric samples slash test network. Yeah, I kind of put this in the wrong spot. You can see how it's duplicated the path. Okay, so that's my slash bin. Okay, now let's try bringing it up.
While you're going there, there's a question here if you could share an alternative for Composer.
Oh, yeah. So Hyperledger Composer was a tool to try to originally they wanted to make it cross-platform, so you could use it with any blockchain, but they kind of focused it on Hyperledger Fabric, and it was to allow you to bring up a network and a channel and put your chain code into it. It was clumsy. It stopped working with version 1.2 of Hyperledger Fabric. And so it's gone. And I think it was good that it's gone because it didn't do anyone any favors. It seemed to get you up and going quickly, but all it did was just caused you a lot of problems and gave you no way to remedy those problems. So it's a lot more work to get your own piece up and going. But unfortunately, that's the way you've got to do it. Oh, cool. So starting nodes with CLI time on 5, pure binary configuration files not found. Okay, so let me go back here, and I'm going to do this install part again. So yeah, so Compose was supposed to make the world easier. It didn't, and it was so different from the workflow of the actual Fabric that it didn't actually help you. It wasn't like you get started with Compose and then you can switch over to regular Fabric. They had different types of ways that they did the chain code. And it was just, it was clumsy and it was ugly, and it didn't do anyone any favors. So yeah, the only way to work on this is unfortunately still the hard way. Well, actually, let me take that back. IBM has a part of the IBM cloud, because they were the originators of this system. It was the IBM blockchain. So if you go into their cloud, they actually have a user interface that allows you to set up your network and to set everything up, and they'll give you a lot of direction on how you're setting it up. And for putting chain code and things like that on there, it's a way better experience than this clumsy interface. So there is the option of using the IBM cloud to run your system. It kind of locks you in with them. You don't have so now I need to change this. So this should be projects, Fabric samples, and then I believe that should just be bin. Okay. All right, now we'll see if we can run our test network. Let's bring our network up. Okay, so you can see how it's doing. Well, that was a lot faster than it's done in the past. I think they've really improved some things. If we go back here, we should see some peer commands. Well, let's kind of go across what it's done. So the first thing that they're doing here is they're doing a crypto gen. What they're doing is, because I'm using TLS security on this, they're going off and they're creating a bunch of public and private keys for all of the different nodes that are going to be used. Because the Docker images that I brought down, they don't have the keys in them. That's the sort of thing that has to be passed in, particularly if you're putting them into a Docker repo. So we're using version 2.2.1. Blah, 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 blah. So it generated a whole bunch of crypto stuff. Okay, so we've got the files for organization 1 and organization 2. It created our Genesis block, which is the beginning of our blockchain network. So we have a channel called system channel, and then okay, so we have a network called net test. These volumes are set up so that when I'm running these Docker containers, they're actually looking back on the hard disk of this machine that we're on. So those are volumes where it's getting the information. we have 2 organizations, an org1 and an org2. And if we take a look at what we get, the output here is we have an orderer. So this is a Docker for our orderer. This is the piece that's going to do the transaction ordering consensus. We have a peer for org1. We have a peer for org2. And we have, a pay ID server. Oh, okay. Pay ID is, I didn't know they added this in. This is really cool. Pay ID is part of the Interledger protocol. And this allows you to set a fully qualified address for endpoints for using cryptocurrency for payment. So you can actually use this to send invoices and request payment and notify that you've actually received payment. Oh, wow, this is, I had no idea they put this in. This is a really powerful thing because, as I said, Hyperledger Fabric does not have a native coin. So what you're doing is you have state information on data that's not a transfer value. And you could use Interledger protocol for using transfer value. This is a really important part of that. That's really cool. I had no idea that was there. So we actually have our network up and running, as we can see here. Let's make sure it's still running. Okay, so these other nodes were just up for a while and they went away. I'm not sure if they went away with error messages, but we're not going to need them for what we're doing. So we've got some peer nodes, and we've got an orderer. Since we are not, I didn't specify CouchDB, it's just going to default back to level DB. Since I didn't set up a certificate authority, it's just going to use a default piece in here. So now let's take a look at FabCar. So FabCar is an example. You know what? I think I can just do, is it .code? Is it code or is it VS Code? No, is it code? I think it's code. Yeah, I just want to bring up Visual Studio Code because it's just going to be easier to take a look at what's in here using this than it would be jumping around through an editor. Oh, we're going to have problems seeing this again, so why don't I just make this? And can I change my font size?
I think if you press Control plus, it'll zoom in for you.
Control plus equals. There we go.
Nice.
Let's do that later. And let's see what we've got here. So I want to open up projects. Oh, here it is, Fabric samples. Great. So let's do that from there. Let's take a look at FabCar. So with FabCar, we have a couple options. You can do FabCar in Go, in Java, and in JavaScript. Oh, TypeScript. This is a new one as well. I haven't used version 2.21, I think it is. I've used version 2.1. So I'm finding new things along with you. So let's take a look at the code they provide here. So we have a bunch of JavaScript files, and so this is actually they are using the JavaScript here to call the Fabric SDK. So if we take a look at the package JSON, we should find yeah, okay, here it is. So they're dependent on the Fabric CA client. So this is to get this certificate authority and Fabric network. And this is going to allow me to connect to the network, to use a channel and access the chain code. Having the Fabric CA client is going to allow me to do things like create users. So let's take a look at this one here, enroll admin. So you can see they're actually using this Fabric CA module and the Fabric Network modules. So these are Node.js modules that can be used. So it's using the network to get the wallet, and it's using this for the certificate authority services, which we're going to need if we are going to work with what they call the membership services, which is basically adding users to the system. There's some pretty straightforward stuff here. They're finding the path to, in this case, so they want to have the connection information, which is how do you connect to the peer nodes for this organization? So in this case, we have a single peer. So this JSON information is going to tell us what address it's at and what port it's at and that sort of thing. We're going to take that and turn that into some JSON data because it's, as you can see, it was stored as JSON data. But when we read it in from a file, it serializes it as text. And so we take that text, turn it back into JSON. So we've got a JSON piece here. We're going to connect up to the certificate authority for org1. We're going to go ahead and get the PEM file. So this gives us the public and private keys to work with. And then we're going to create the services piece. And yeah, so now we've got a thing that can connect up to the Fabric network. We're going to create a wallet. So this is a non-custodial type of system. So when I create a wallet, that means I need to create something locally on whatever system I'm running. In this case, it's my Ubuntu instance that I'm running. So it's going to create a wallet folder, and it's going to create a wallet that has a certificate inside it. And the types of certificates they use is a standard called a X509 cert, which basically holds the public and private key and some other information. And that cert can be accessed in specific ways. And then it checks to see, hey, do I already have something called admin in this wallet? If I do, don't need to create a new one. Okay. Otherwise, go ahead and this is the connection to the certificate authority that we had created up here. Enroll admin, and then this admin enrollment secret password. I should tell you where that came from. So if we go back to test network here. So in test network, let's look at Docker. Here we go. So when we're doing Docker Compose, we're telling it how we want the specific nodes to be set up. In this case, we're setting up a org1 node, and we're telling it, hey, this is where you're going to be set up. Here's the name of your organization. We're running TLS security on here, so this is like SSL type stuff. Here's the port we're going to use, and somewhere in here, there you go. Here's the password here. So we're passing into this because we don't want to have our Docker container to have the password built into it. It's something that when we have the container up and running, we want to pass to it. So we're basically saying, hey, start this thing up and pass in this password admin PW. And that's where we were doing the enroll admin. That's where this comes from. It creates the X509 identity for this person, and it sticks that into the wallet under admin. Okay, and then we've enrolled an administrator. So let's try that out. Yes. Let's go to JavaScript, and let's do // was it enroll admin. Oh, can I run it this way, or do I have to do npm on this? I think I have to need to do npm. Yeah, let's try that. Oh, you know what I need to do is npm install. So I need to bring down all the modules, so I don't have the Fabric SDK yet. So this will bring that down, and plus the other things I need. So the interesting thing here is when I brought the network up, this network already had the Chaincode installed. And when we get to the point where we're going to run the Chaincode, I'll show you that, and I'll show you how it's installed as part of the Docker and it's bringing in. So normally you don't do that. You bring up the Chaincode for each thing. So what was that? So let's try. No, so it's not npm. Oh, it's node. Okay. So why is it unhappy here? Failed to enroll admin. Message calling, enrollment endpoint failed with error. Connection refused. Oh, 7054, which was the port we had. So remember when we looked down here, 7054. Okay, so I think what's happening here is we need to tell it that we want. So let's bring the network down again. Was it test-network? Yeah. /network.sh down. So let's bring that down. I'm going to bring it up, but I want to tell it that I want a certificate authority here. Okay, so let's just call up the options. This should tell us what options we have. Okay, oh, I see. Yeah, so we need to bring it up, and then we want to create a channel, and in the channel we want to have our certificate authority. Okay, so let's /network.sh. We want to bring it up. Let's put a CA right at this point. And I think we're good. I don't think we need the other. Oh, let's create a channel. Let's call it my channel. That's what we'll do. Okay, and what this will do is it'll include these two organizations inside this channel. Okay, it's using level DB because I didn't tell it to use CouchDB. I could have put a -s space CouchDB, and then it would create CouchDB for us. Okay, so now we have our peers for org 1, org 2. We have an order, but now we have a certificate authority for org 1 and a certificate authority for org 2. Okay, so let's go back and go to put the admin in. So that was fatcar JavaScript, and let's do /. Oh, so we want to do node enroll admin. There we go. So now we have our administrator in our wallet, and a matter of fact, we can see we have a wallet folder. And if we look at what's in wallet, we have admin ID, and let's see, the X509s are somewhat human readable. So let's take a look at that. Here we go. So in our admin wallet, it's a key value pair. So this is JSON data. So our credentials are, we have another key value pair. So we have a certificate. So this is our private key, or sorry, no, it's a PEM key. So we have a public key and a private key. We're using org1's membership services provider, which is basically the certificate authority we're using. The type of this is X509, and the user is Dave. Okay, so we've created this. So we have an admin user. So if we want to do some admin things, we've got that. But let's create a regular user. So we have now code for, oops, not that, but this one here. Let's go back up and let's take a look at register user. So your register user code is pretty much the same. So we're going to the network to get us the wallet. We're going to the CA client to get us the certificate authority stuff. We go through pretty much the same thing. We check to see if the wallet, if there's already someone called app user in there. And if not, then we enroll them and we create the wallet. Okay. What we're doing here is the reasons why we set up the admin is a person can't add themselves to this organization. The admin has to do it. So when we're going to add a user, so we're going to register a user here, we have to do it in the context of the admin user. Okay, so that's where I'm setting this all up. Okay, so that'll create a user for us, so we should just be able to do that. So node register user. Okay, so we've created a user called app user, and if we look at wallet, we have X509s for admin and for app user. Now what we want to do, I believe, is we want to invoke. So the chain code, and let's take a look at the chain code. That makes good sense. Let's do that. So if we take a look at Fabcar, let's go with chain code here. So chain code, Fabcar, JavaScript, and should be here under lib. Here we go, Fabcar.js. So here's the chain code that we've got. Basically, it's kind of, in this case, it's using a piece that simplifies it a bit. So there's a node module Fabric contract API, and it gives us a class called contract that we can use. And it simplifies the interface to this. You can do it without this, but then there's a whole bunch of STEM stuff that you've got to do that's a little tricky. So here's what it's going to do is when we first set this thing up, it's going to init our ledger. And so in this case, it's just going to stick some data in. This is our state data we're going to use. It's going to set up a bunch of cars. So we have a blue Toyota Prius. We have a red Ford Mustang, a green Hyundai Tucson, and then basically who the owner of these things are. So this is just whatever data they're sticking in. And then it does a put state on this. So what the put state is it's going to put this into the database. In this case, we're not using CouchDB. It's going to use LevelDB. So it's just going to store it as text string. It's not going to be able to natively deal with it as JSON. And then it's giving a key to it. So car and then whatever number. And then whatever JSON data we had. It's going to stringify that. It buffers this. This is to put it in as it's basically binary data at this point. So if you have a buffer, it'll deal with binary data. You can't pass a string into this. It's just the way, because you can use multiple languages for talking to Hyperledger Fabric chain code. So it just says, okay, I don't care what your language representation of a string is because I'm not going to understand it. So you got to send this to me as a binary block. That's why you have to do this buffering part here. And you can see later on, if we call it query car, it's going to do get state to get this stuff back. And it'll show it to us. So let's go back and we are going to do the, well, let's just do the query. So let's say node query.js. Oh, access denied. Oh, it's not allowing us to join my channel. Okay, well, this is an interesting thing to see. So if we go back to, maybe if I go back to, oops, where did I have? This one here. If we go here and we take a look at the diagram. So when we have a channel, the channel has the different organizations in it, and each channel also has its own chain code. So I think the chain code that was installed as part of the blockchain isn't in my channel, it's in a different channel name. So that's why I wasn't able to call that. Okay, that's a shame. Let's go back to our command line here. How can I put that in there? Okay, let's go to the network, and I'm going to not give it a channel name. We're going to use whatever channel they want. So we'll bring the network down. Let's go to test network /network sh. Let's tell this thing to bring it down. So this is going to tear down the network. It's going to stop all of the Docker containers and remove them. So you can see how we have a peer for each organization. We have a certificate authority for each organization. We've got our orderer, blah, 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 blah. So let's bring this back up again. So let's use the, this time I'm not going to specify the name of the channel. I think it has a different channel name that it's using. So let's just default whatever they have. We should be able to see somewhere in there what the channel name is. Okay, so since we brought that down and we killed it, we wiped everything out, it won't have our admin anymore and it won't have our user. So we're going to go fabcar, JavaScript, and we will do node enroll admin. We will do node, I'm going to remove wallet. Okay, so let's go back to enroll admin. Let's do node register user. Okay, now let's try node query. Oh, okay. Is there something I need to run before that? What's inside invoke? I think invoke is a bit different than query, so let's take a look at that. I think invoke is actually making a change to the code as opposed to, oh, here we go. So query, create car, query all car. Oh, okay. So we need to go back to, here we go. So invoke, blah, 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 blah. Creates a new file system object. We get a wallet. So it's going to do this as this user. Create a new gateway for connecting to our peer node. Okay, so let's take a look at this because this is a little bit different than what we were seeing before when we just were adding the users and administrator. So now on top of Fabric Network getting the wallet, we're also getting the interface for the gateway. So the gateway is how we're going to connect up to the peer node. So we do all the wallet stuff. That's all fine. The next thing is we create one of these gateway objects, and we're using it. We're going to connect to the CCP. Remember, was the information on the organization. So how to connect to that organization. And we're going to say use in the wallet of the app user. Okay. Once you've got the gateway, and you want to get the network called My Channel. Okay. And then from that network, we should be able to get the FabCar contract. Oh, okay. So this is confusing because they're actually using channel here. So so we didn't have to specify My Channel because that's the default one that they use. So now we've got this network object. It should be able to get the FabCar contract for us. So this is where it's failing for us, which is we are connecting. So we've got this gateway piece. Get the network channel for our contract. So it's trying to do this get network on My Channel. Is that where the error happens? My Channel error, access denied. So My Channel received discovery error, access denied. Well, let's stick, because we're using JavaScript here, we can put some debug messages in here. Let's put console log. So this is get network. And let's do get contract. Which one is this failing on? Oh, did I modify query.js? Which one did I modify? Oh, I did that on invoke. I want to do that on query. Not sure if you can hear that in the background. There's some sort of dogfight going on. Okay, so we want to check if we can get to the network. And we want to check if we can get the contract. Okay, so we did get network, and then it was not able to connect. Okay, so now we've established that it's this command that's giving us a problem, and it's trying to connect to My Channel. So let's scroll back. When we set this up, we should see where it's trying to add these things to the channel. So let's go with what's happening here. So we brought the network down, that's fine. So we're bringing our network up and we're telling it to add a certificate authority. Great. So we get our certificate authorities up and our orderer up. We create our org1. So this is, we're trying to enroll. Okay, so TLS cert. Okay, so it's creating the admin user here. Register peer 0. So register user, register org admin, generate the peer 0 MSP, the TLS certs, the user MSP. So what I want to do is I want to find where it's adding this organization to the channel. So I want to see if that failed. So here's the peer 0, user admin, MSP, TLS certs, generate that. Create order org identities. Okay, that's fine. Order MSP, order TLS certs, admin MSP, generating order genesis block. Okay. Creating volume. Oh, I don't see where it's added. Okay, so that is probably the piece we're missing. Was it this one? No. Where was that? No, not that. This one here. Okay, so when I ran the network, okay, so let's go here. So using the test network. Okay, so we brought up the network. Now I think we need to add the, here we go. We need to create a channel. Okay, and this is going to make the things join the channel. Okay, so this is what we want. Sure, why don't we call it channel 1? So let's try that out. Let's do Okay, so when it creates the channel, it should then invite the orgs to that channel. Join org1 peers to the channel. Here we go. Great. Org2 peers to the channel. Okay, so now they're part of this channel. So, and it's called channel 1. So let's go back to Fabcar, JavaScript. Okay, and let's take a look at this query code. We're in query. I think we're going to have to tell it channel 1. Okay, so let's try this. Node query. Oh, so we don't have that on channel 1. Okay, so let's go back and let's go to test network, and let's do a create channel, but let's call it my channel. Let's add these things to my channel. So again, we're joining these organizations to this channel. So if we go back to the diagram I had, we're taking org1, org2, and we're putting them into, in this case, it'll be my channel. Okay, so they're part of that. Fabcar, JavaScript, and let's do node query.js. Okay, so it got the network. Oh, contract. Make sure the Chaincode Fabcar has been successfully defined on channel. Okay, so I think we're going to have to go and install this. And this is a real pain to do this. Why wasn't it put in for us already? Well, I'm going to actually look at what they tell you how to do this. Starting a chain code on the channel. Okay. Okay, so let's deploy chain code. Oh, wow, do we have to do all this? Let's try this out. Let's do /// test. Was it a further? No. Okay, so we want to do deploy Chaincode. Why did this fail? Okay, so deploying Chaincode on channel my channel. Okay, determine the path to Chaincode. Great. Oh, so this is Go Chaincode it's doing. So I think we need to tell it which language we're using. Oops. Yeah, Chaincode language JavaScript. All right, so let's do, oh, they're actually giving us examples here. So my Chaincode, so this is new. So let's do /network.sh deploy Chaincode. So let's say Chaincode language JavaScript. So here we are putting it on org1. So this is, remember I talked about you had to sign it, you had to instantiate it, you had to approve it. So this is the installing it, which is instantiating it here. So this is a, tar is a Linux thing, it's tape archive. It's basically, it's a way of doing zip files. So this is a gimful zip standard for that. It's an algorithm for compressing things. Now, an interesting thing of what they do here is when you install Chaincode this way, is they're actually creating versions. So there's actually a new Docker container. It's a very small one, is created with this package of Chaincode on it. So it can get a little confusing. You may have a whole bunch of Docker containers based with the versions of Chaincode that you have. Once this is up and running, we'll take a look at the Docker PS, and you'll see that you end up with multiple of these things. And at first, I thought that was some sort of bug, or some sort of problem. It was a while until I realized that you can have multiple versions of this running. There we go. So it's installed. Here's the payload for this. It's sticking it onto organization 2. And when it gets both of them on there, it's going to approve from each organization, and then it's going to invoke that Chaincode. Remember how I said this is orders of magnitude more complicated than Ethereum? Yes, it is. When you go through this, follow the directions. I'm not great at following directions. I just kind of do it the way I want to do it, which obviously has run us into a few problems, but it's good. You can see different ways that we can sort of check for errors. And remember I said that what you want to do is you want to get your stuff working just fine before you go and do a lot of putting it on the network. Because the great thing is if you've written this in Go or JavaScript or Java or whatever language, is you can simulate, what I do is I simulate writing to the CouchDB by using MongoDB. So I'm doing a project right now with the Cybersecurity Research Lab at Ryerson where we were doing decentralized workflows, and the workflows are represented by data-driven state machines. And so the rendering of the state machines, we're doing this all, currently we're doing it in JavaScript. I think later we're going to switch it to Go. But to get it working, we're doing the whole thing just using Node. So we're not doing it actually as Chaincode just yet. We want to make sure that we're quite happy with it and it works fine. And then we're going to actually put it into Chaincode, because if every iteration we have to do, we have to then stick it up there, it's painful. So let's do the Docker PS, and I'm going to show you. So now we have, these are two new Docker containers that basically represent that version of Chaincode that I've put on there. So there's the original Chaincode, and now here's the new one that I've installed. So you end up with a bunch of these for your Chaincode, and it can get confusing. You're like, why is there a container there? But they're very small. They don't use up a lot. It's pretty straightforward stuff. Okay, so now we should be able to go and run our Chaincode. So let's go fabcar, JavaScript. Okay, let's make sure that in query, I'm not using channel 1, but it should be my channel. Okay, now we're going to run our query.js. So node query.js, and this should give us the cars. Successfully defined on channel my channel, and then try again. Chaincode 5 car not found. So we've deployed it. Why? Oh, because we need to invoke it. If you use the deploy to install and start the asset transfer basic Chaincode, you can invoke the init ledger. Oh, did I do the language? Okay, let me go back and see what I did there. Did I specify? Yeah, Chaincode language JavaScript. Well, let's try doing the invoke. And let's see if that's what's required. So let's go up here. And so it's peer Chaincode invoke. Localhost 7050, so that should be the org1's peer node. Blah, 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 blah. PM. My channel is what we're using. It's basic. Okay. It may not like that. We'll see. Okay, and we don't want to call init ledger. We wish to call, or is it init ledger? Let's go back to here and let's take a look at, let's go to the actual Chaincode itself. Oh, and the call is init ledger. Okay, great. So am I going to have to set up the present working directory? No, I think that should be it. Oh, here we go. So we set up to the bin. You also need to set the Fabric config path to point to the core YAML file in Fabric samples repo. Okay. Well, let's take a look at that file. What is it that we're doing with that? So let's go to the Fabric samples. So that's this fabcar folder. And oh, they have a network thing right here. Is this going to do it for us? Oh, interesting. Okay, so I think we can do this instead of the network we ran. I think this might make things easier for us. So let's just go back. Oops. So let's go to test network. Let's bring that network down. Network.sh down. Doot, 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 doot. And if we actually go into that fabcar folder, they had a command there that would bring the network up, and I think it's going to install all of the chain code for us. So just for expediency purposes, we will use that. So if we go into here, yeah, so we have a start fabric. So let's find out what the options are on this. Oh, well, I hope it's the option is JavaScript. Let's find out. Well, let's watch what they're doing here. Or it's going a little fast. So this is setting up all of the crypto stuff, the Genesis block. It's pulling down the Docker containers that we need. Oh, we do have some questions here. So here's a question about Hyperledger Quilt. Can this be used for interledger interaction with Hyperledger Fabric and other solutions like Indy? Oh, I'm not even familiar with Quilt, so I can't really answer that. Please compare Hyperledger Grid with respect to supply chain. Again, I'm no expert on Grid, so I can't really answer that one either.
Yeah, I was going to keep those towards the end if we had time to get to them, but you just cleared them up for us real quick.
Yeah, I hope everyone's got a little bit of time. It's just going to, I think we'll be there in about 5 minutes.
Cool.
So here we are. It's setting up our organizations. Yeah, so this one command is doing everything for us. Chaincode packaging on peer 0 org 1 has failed. Okay, boo. So it's trying to use the Golang. So let's take a look at what are the options here, because we want this to use JavaScript. Okay, so source language. So, well, thanks for telling us what the options are here. Chaincode languages not supported by the script. Supported chain languages are Go, Java, JavaScript, and TypeScript. Oh, so I think I just put in just JavaScript. So what is the no, these guys don't tell you that part, do they? Okay. So let's try that again. So once we get this up, if we take a look back at the code, so what query is going to do is because you have to, even if you're just calling it when you're not changing the state data like this is going to do, you need to do it in the context of a user. So I need to go get the wallet, and I want to get the wallet for app user. And then I'm going to have app user connect up to the network. Okay, once they're connected to the network, I want them to connect to my channel. And because app user is part of org1, and org1 is part of my channel, they should be able to connect to that. And then we want to get the FabCar code. So we want to bring down the chain code for this, or at least a connection to that. And so that gives us a connection to the chain code. And then I can do an evaluate transaction. So an evaluate transaction is kind of like in Ethereum, you have the option of running things where it's going to just do a read of the blockchain, and one where it's going to do a write. So evaluate is just, it happens really fast. It goes off and grabs some data and it comes back. If I did a, what's the opposite of evaluate transaction? Well, we can see that in the invoke code. The invoke code is going to do submit transaction, yeah. So if I do a submit transaction, it's going to make a change to the state data, which means it takes a little bit longer for this transaction to go through because it actually has to commit. And everything has to be approved for it to come back. So a submit transaction takes longer than a evaluate transaction. But if you try to do a evaluate transaction and then it actually tries to make a change, it'll just fail on you. So in the case of the query all cars, it's just going to return back the JSON data. Whereas in this one, which is doing create car, we're adding a new record. So we're going to do a Honda Accord Black with Tom as the owner. So where are we here? Okay, great. So now we should be able to, so we're here, let's say JavaScript. Okay. Let's get the wallet. Let's do node. Enroll admin. Okay, let's do node register user. Okay, now we should be able to do node query. There we go. Now we worked. So we went and called. So let's take a look at the actual chain code itself. That start network thing actually called the invoke, which made all of this happen. Okay, and then we did a query car. So we say, okay, get state car number. Oh, so I don't have a car number. So I think it was query all cars. Yes, here, that's what we did query all cars. So if we look back here, it's query all cars, not a specific car. Okay, so it says, okay, we need a starting key and an ender key, and we're going to put everything into all results. Okay, so it's going to walk through, here's a nice command here, get state by range. So I can go across all of the keys. What this is doing is, because I've got sort of JSON data there, I can actually walk through these. And whereas, let's say in the world like Ethereum, you can't actually iterate across a collection. In this case, I can iterate. Okay, and then I'm going to get the results back, stick that into this, parse it, push it into my all results array, and then loop all the way through until I've gone through every single entry, and then return the results back as a, I hate when it does that thing for me, a JSON string. That comes back to my part here. So I've put this into result, and great, and I'm just going to spit this out as a string, and that's what we're getting right here. Okay, I should be able to add that new car. So let's do the node invoke. Okay, and so this is going to add Tom's Honda, which is not in this list. Okay, and now let's do the query again. And this time we'll have, where's Tom's Honda? It should be in here somewhere. Can anyone spot it? Okay. Anyways, this is the very basic example. So what we did here was let's jump back to here. So what we did is we set up our own network. In the network, we had two organizations. We set up a channel between those two organizations. We set up some chain code, and we created an admin for each organization. The admin accepted a user, the user for org1, and that user we used to call the chain code, and then the chain code spat out that data. So that's kind of the path we cut through here. So there's a lot of things that you can do with Hyperledger Fabric, but you need to spend a lot of time solving problems to get this thing to work. So it's a really good experience just to try to get the fab car up and working. If you can get that working, there's some other examples they have, but what I would suggest instead is try writing your own piece of chain code. So if we go back here and look at where they had this fabcar.js, so they had under JavaScript here, so you could create another folder underneath this, and then put in another JavaScript piece in there. How did I do it? I think I put mine at the same level as this. You will find that you'll have to probably change the YAML files. All right, so we have fabric samples. No, we want to find, where's the, somewhere there should be the YAML file for the test network. And in that, that'll have the volumes it's bringing in. So what it's actually doing is, oh, here we go, here's test network right here. Docker. Test network YAML. Okay, here we go. So here's our peer nodes. And we should find, here we go. So the volumes here, these somehow should map to the fabric samples folder. How does this do it? Order example. Because what it should do is it should take that the fabric samples folder and include that into the Docker container. Docker containers are static. They don't have, there's no disk space included with the Docker container where you can add files and things. So what you do is you map them to a volume. In some case, let's say on AWS, you'll map it to like an S3 storage. In this case, it's on my local machine, so I'm mapping it to my local hard disk. So what I've got on my local hard disk is mapping to a folder that appears inside the Docker container. And that's how I can get things like I'm generating the cert files on my local machine when I did that crypto config. And then it's taking these and putting them into the Docker container. Okay, so that was a lot to throw at you in like 2 hours or so. Are there any questions or anyone have any comments or anything? It's a big piece to learn, but it's a very powerful system with a lot of things you can do.
Yeah, that was quite the journey that we went on. It's always interesting to see, live debugging and how an expert such as yourself like breaks a problem into smaller pieces and steps through it. So that was great to see. And a great part of what we're doing here is we have this as a piece of content moving forward, so folks can go back and step through the entire workshop at their own pace and slow it down at certain parts or speed up at certain parts too. So that's really great. I want to thank you very much, Dave, for giving that all to us. And to your point when you said working with Hyperledger Fabric is orders of magnitude more complex than working with Ethereum. It appeared very evident as you're going through. But I wanted to ask, like, do you see steps being taken to become a little bit more user friendly, a little bit more developer friendly as time goes on? Like we know with Ethereum, you have things like Remix and Truffle, where things are kind of abstracted away and sped up for you. Do you see that kind of process happening with Hyperledger Fabric?
I don't personally see that. So some people suggested, have you checked out these other tools? Maybe those improve the experience. The problem, and they found this with the Composer, the Hyperledger Composer, because they had spent a lot of time working on that and it wasn't quite working yet. And then the rug got pulled out from underneath them. So Hyperledger Fabric went from 1.1 to 1.2 to 1.3 to 1.4. And so in going from 1.2 to 1.3, it broke it. And I think the team just like, they started crying and gave up.
Yeah.
So I don't blame them. So it's until the system stabilizes a bit more, I don't think we're going to see much in the way of help. But I think what would really help would be, and maybe this is the approach the IBM is starting to take by having the Visual Studio Code plugin that will do a lot of things for you, like setting up your network and getting that up and running. That was probably half the work I did was try to get that network up and going and get my certificate authority and all of those things, and getting the channel up there and getting the Chaincode in the channel and then the rights set to it so we can call it. So a lot of that stuff to be taken care of for you. But because there are so many options, it's a very big task for someone to set up a system like that. And then what they might end up doing is burying certain settings that you should understand to change it. So unfortunately, I think it's going to be a bit of a consultant wear. What I mean by that is Microsoft had this thing, what's it called again? It was sort of Microsoft's equivalent of a wiki, which was just SharePoint. So SharePoint was just this horrible behemoth that was impossible to work with. So you had to pay these consultants a lot of money to come and play with it. So I think Fabric's going to remain that way for a few years. So if you want to get, if you want to be in blockchain and you want to get some corporate bucks, if you don't mind working for, soulless corporations, then it's a good gig to take on, because there aren't many people that have this expertise, and it takes some work. You got to dig on this stuff, and you got to trial and error it, and you got to make it work. So if you run into problems, you won't be able to get through as fast as I did, because I've set up dozens of these networks. I mainly struggled because there's changes between version to version, but I've got a pretty good handle on how they're doing things. But it takes time to get there. So if this is your thing, go for it. If not, run away right now.
Yeah, I think it really highlights the differences in approach. Like, we're building things for enterprise, which they need to have control over certain parameters and make sure that their security is really important to them. So the certificates you're generating, only the approved people can get those, and all that. And it also, I think, kind of speaks to typically, and what you said also earlier, is typically with corporations, they tend to move slower. They need to get all the members, all the different corporations involved, approval before they make changes, and that process takes more time. There's a little bit more red tape, and I think that kind of reflects in in implementing things in Hyperledger. So there's trade-offs, but there's also benefits that are involved. And going back to what we were talking about at the very top, using the right tool for the right job. So I think that was well highlighted in this workshop. We do have a question here from the audience. Someone's asking, how do they collaborate with you? Is there a way that they can work on a project with you and to continue to learn in this space?
So there's 2 projects you can collaborate with me on. One is for the self-sovereign identity. I have the Canadian Credential Network, and that is a not-for-profit organization, and it's all volunteer-driven. And I'm working with people for the actual coding of mobile agents, for the sysops for the network itself. We have things like we're trying to work out education to get people educated on it, engagement, governance. So there's a lot of different areas of things we're working at for there. If you are a Ryerson student, the Ryerson Cybersecurity Research Lab likes to bring on students as research assistants. And so there's always positions for that. And for that, we're working with both Hyperledger Fabric and we're working with self-sovereign identity. That's a Hyperledger Indie and Hyperledger Aries projects, as well as the Interledger protocol. Outside of that, like for example, for this hackathon, I'm doing mentoring for groups, because as well as the technical side, I have a lot of experience in working with investors and presenting ideas and just how to position your project. So every Friday, I think next week is the last week. I'm not sure about that. But you can sign up for a mentoring session with me for next week. Other than that, if I can put in here, Dave at gamacred.ca, and also my LinkedIn profile. Let's see if I can call that up.
Handy here. It's definitely in the event description for folks to find.
I just threw that in the chat as well. Awesome. So if you want, contact me on these. I'm always interested in whatever blockchain projects are going on. I'm usually involved in about 10 projects at once. So, I can't give you all my time unless you have a big pile of money. Then you get all my time.
Nice. Yeah. And yeah, like you said, like working for the soulless corporations typically does pay, and there's a huge need for the coders in this space right now. So that's awesome. Thank you so much for being here, Dave. It was a blast. I learned a ton, and I definitely need to rewatch and go through at my own pace. Like working with trying to do this while streaming, it was like slowing down my machine like crazy. So it's definitely one that I'll go back to. So for the folks that are still hanging out with us, I'd like to thank you for being here. Let's take a look at the poll that we had. So there was some folks with some Hyperledger Fabric expertise already, and a ton of folks that are eager to learn some more. So I hope they learned a bunch today. And we had quite a few Ethereum devs that were coming across to learn some more about Hyperledger Fabric. And typically folks want to build consumer products, but there is a sizable portion of folks that want to build both consumer and enterprise products, but still also some folks that want to build solely for enterprise. That's awesome to see. Nice spectrum of folks coming out. So thank you all for tuning in. Just a reminder, if you haven't already signed up for BlockHack, it's still not too late. We have a few more weeks left to build projects that have an opportunity to get seed funding. So if you take a look down below, there's a link to our resource hub. There are links from there all to our Discord and to the application form to sign up for BlockHack. And also, like Dave mentioned, he's offering portions of his time per week for people that want one-on-one mentorship while they're building their their projects. So you can find them over in Discord once you get into the whole flow of the hackathon. So I will see you over in the Discord. And also, take a look. I think I'm pointing in the right direction. Just above, there's going to be a follow button. You can follow us on Crowdcast, and you will get informed when we are going live for all of our workshops and talks. We got a ton more great ones coming up for you. And we have another one this evening based in the Ethereum ecospace. So if you're eager to learn a little bit more about listening to events in Ethereum, come check that out. And of course, if you go to the portal, you will see a schedule of all our upcoming talks. So on that note, again, thank you so much, Dave, for being here. It's been a blast. And I will see everybody coming out to the next workshop later on today. Until then, I'll see you in the Discord, and I'll see you in the next workshop. Take care, everybody.
Bye, everyone.